As a developer, you are very likely to encounter recurring problems and problems which have been already solved. So instead of reinventing the wheel, if as a developer I'm trying to employ these design patterns, there's a higher likelihood of success with minimal effort.
Hey Vikash, how are you?
I'm good, Saransh. How about yourself?
I'm good too. I thought we should discuss design patterns today.
That's an interesting topic. What do you want to talk about in that?
Let's start with the definition first.
Sure. Design patterns. Back in the day when software engineering was happening, a lot of smart engineers and researchers found reusable solutions for commonly occurring problems. This is primarily for object-oriented programming languages and cannot be mapped to functional languages like Haskell or any functional programming paradigm. So, when they discovered or found these commonly occurring problems, they tried to package this and present it to the readers and developers as a design pattern. Uh, this essentially means that if you're facing similar issues with your uh, tech problem, there's already a solution available that you can use readily and make your code more robust and more structured and maintainable as you go. I think that's a very layman explanation for people to understand. There is obviously more nitty gritties involved, but I think for this discussion, let's stick with that.
So, one thing I would like you to elaborate a bit more on when you say they are not applicable on functional programming. So, are there different patterns for functional programming or do they just not exist at all?
There is an excellent talk on design patterns and functional programming by Jake. I am happy to um, share that link with you as well. In functional programming, everything is a function. There are different types of functions. There are different usage and declaration of functions, but everything remains a function. So um, you have things like monads and monoids, which makes the code more robust and structured, and it helps you structure your code better. And that's one of the reasons that you cannot apply the object oriented paradigms in the same fashion in functional programming languages.
So, you're saying there are patterns, but there are different patterns.
Yes, I would say so.
Okay. And what is the need of a design pattern? I mean, you touched a bit upon it, but as a developer, when are they useful and why should I even care?
As a developer, you are very likely to encounter recurring problems and problems which have been already solved. So instead of reinventing the wheel, if as a developer I'm trying to employ these design patterns, there's a higher likelihood of success with minimal effort. Additionally, it gives you a good grammar to interact with other engineers in the domain. So your conversations and exchange of thoughts is much richer. So I think there's a real world use case of solving engineering problems. Additionally, there is a soft skill development as well, where you're able to communicate your thoughts better.
Yeah, definitely. I've had instances where I was having communication with a few peers and I was like, yeah, I just did this pattern and they understood it and we didn't have to get into the specifics of what I did. So it definitely improves or reduces the time of understanding things if both the parties know of this. But many a times, if someone does not, then it becomes you have to explain the whole thing to them.
Sure, I think that works both ways. So definitely, if I am interacting with someone that is not aware of a particular pattern, or somebody's talking to me where I am not aware of a particular pattern, that discussions can go longer. But if we both are aware of a particular common point, the conversation is much shorter and we are able to come to conclusions much quicker.
I I was recently watching a talk, and it was related to communication skills, but the guy was saying, "Hey, why do you have to make? Why it was about some other industry, but they said, why do you have to make things so complicated when you say this and this?" And the other guy said, every industry has their own terms, so that's the terminology that they use to communicate with similar people.
Sure.
And I
I
think
am
design patterns are that thing for developers.
definitely, it's a little nuanced for developers. Um, so I remember when I started my job in one of my previous companies, that's when I picked up design patterns for the first time. I read about Gang of Four, which is, I think, is one of the most prominent books um, in the domain. Which I think, if I recall correctly, it was released in 1994. So it's beyond me. That's something that was released decades ago. Still makes sense and works for multiple problems that we encounter today.
Another thing that I would like to add to that is it might also happen that you think you are creating something new, but I've almost always ended up either using a design pattern, or I've kind of mixed two design patterns and used a combination of both.
Right.
But I once I was in the process of writing it, and then I finished it, and then I realized, okay, this was a combination of this and this. So the mix and match does happen, but in the end, the building blocks remain whatever those gang of four people wrote.
Definitely, I think it completely makes sense. Just to give an example, so a lot of people will who have been programming for a while now know that composition works.
Mhm.
They know that you can, if the interfaces are same, or there is a common interface between two functions, then you can work with them together and create a mega function, which is the basis of functional programming. And in object-oriented programming, it's called uh, compositability, right? Or in a better word, it's called the composite design pattern, where you compose objects into tree structures to represent your hierarchies as you go through the software.
I think you jumped the gun here a bit. Let's first talk about the three types of patterns and then get into the specifics.
Definitely, I'm sure I jumped the guns here. It's such an interesting topic that I'm unable to hold my excitement. Essentially, we have three patterns. We have a creational pattern, a structural pattern, and a behavior pattern. Creational pattern talks about how to create objects based on a required criteria. Structural pattern generally talks about organizing different classes and objects to form a larger structure, whereas behavioral pattern talks about the common communication pattern between objects in general. So how will one object communicate with another objects?
We've covered three classifications, but under these classifications, there's too many design patterns under them. So, can you elaborate on why there are so many patterns?
Indeed, that's correct. We have a lot of patterns even in these classifications. For example, in creational pattern, we have abstract factory, we have got builder, we have got factory, dependency injection, singleton, multi-ton, object pool, etc. Right? But each of these design patterns are designed to solve a different problem altogether. For example, if I am writing an application where I want one instance of a class in in the entire application, which acts as a global store or a global point of entry, then I would probably go with singleton pattern. And in this, I'm still creating an object, right? Similarly, I have a factory pattern in which I define interfaces which the client teams can use and build their factory methods and generate a single object based on the interface. Whereas in abstract factory, the idea is of creating families of related or dependent objects, right? So even in a even the genre of the problem might be one, but the problems are different, and that is essentially what drives towards having these multiple design patterns, even for one classification.
Yeah, as there's a common saying in software development, there's no silver bullet.
Yeah, there's no silver bullet. I think I'll not say that there is a red pill or a blue pill, but there's bunch of pills, right? So it depends on you which one you want to take.
And all of them lead to frustration.
I'm I can neither agree nor deny to that.
Now that we know that there's three classifications and then a ton of patterns under them, how do you identify which one to use in which scenario?
Well, my first instinct is to say it depends, but I would try to get away from that. Uh, I think my tip is identify the problem, and that identification of the problem takes a lot of effort. So the first step that I would do when I have to use a particular design pattern is not to force myself. That's the first step. It should be organic and it should come natural. If you're trying to force a design pattern, it's like using a different key for a different lock, right? So in order to investigate what uh, design pattern or what is the scope of the problem, I think I would first dive deep on the problem. What is it that I'm trying to solve for? Am I trying to solve for a shared state problem? Am I trying to solve for that my if I let's say I'm writing a common utility, am I trying to solve for my client teams are unable to extend on a particular feature? Am I trying to solve for reducing code duplication? So identifying these problems and then applying a design pattern is much more natural. For example, I'll give an example of a decorator pattern, right? And so a decorator is a function which takes function as an argument and applies the parent function to this, right? This is again similar to composability to an extent. You can compose multiple functions. You can do f of a or f of g of x or something like that. But if you start and try to say, hey, let's start with a decorator pattern and let's write a decorator, it's probably an overkill. Maybe it's not the right solution at that point of time. You didn't identify the use case, or you were not completely aware of the scope of the problem. Instead, what I would do is I would first write the function itself and then try to find out, hey, if I need to use it, can I put it at one place and then use it? If I can do that, should I go with composability or decorator, or what makes sense? Are there other use cases as well? So I would approach that problem from that direction.
It depends can be a standard answer to almost everything in software development, but you did cover quite a few good points. Another thing which I would at least recommend junior developers or people who are not familiar with the patterns is go and at least read all the patterns once so that you know which pattern exists and how to apply it. And then when you're solving the problem, you'll know which one fits in the scenario instead of figuring out the pattern when you are doing it. First, go through the patterns, have an idea of what every pattern means.
Definitely, I think that's the right thing to do. Start with Gang of Four, or a blog or a video. Start small, and I think on top of that, my recommendation is once you know something, try to use it on production. But again, don't do this aggressively. Let it come natural. Think of a problem and then try to employ it. But once you deploy anything to production, you know that you've done the right thing.
Another point I think which is valuable for anyone getting started is read the solid principles first. They give you a precursor to why you are implementing something and then jump into design patterns.
Definitely. I think solid principle is something which is again emphasizes on code reusability, emphasizes on the best practices. Things like, so in solid principle, every character of solid SOLID stands for something like S stands for single responsibility principle, which in general talks about that this particular function or a class is responsible only and only for one thing. Then O stands for open and closed principle, where it says software is open for extension but closed for modification. Um, I think I is for the interface segregation. So it makes a lot of difference for developers to understand that, and especially in the early stages of programming, it can it will enable developers to write more robust code. As a rule of thumb, there is another principle I would recommend. It's called KISS. Whenever you're confused, it stands for keep it simple, stupid, right? So that is another principle I would recommend people to know when you're designing a or you're working on a complex problem. It's when it's better to keep things simple.
Yeah, there's too many other acronyms I can throw in, like dry, Yagni, and so
Yeah,
on and so forth.
yeah,
But a lot of it is just that has been my approach to a lot of programming in general, that first write the most basic thing that you can think of, make it work, and then think about, hey, this is not scalable, and then refactor it instead of just optimizing initially and then just screwing it up badly later.
definitely. And when nothing works, uh, commenting to do and fix me in your code works, right?
As long as you get back to the to do.
As long as you get back to it, as long as it gets prioritized. But yeah, having that to do's and fix me essentially um, n- enforces to an extent that you are able to solve a particular problem in a much more scalable way. And I think I'm guilty of it. As rosy as it sounds, there are a lot of fix me's and to do's that I've written, but I haven't had the opportunity to work on them yet.
Yeah, I'm in the same boat, but one thing I've not started, but I've been doing for at least 3-4 years is I create stories for them in the backlog as well,
Yeah.
so that somebody does it at some point at least.
Yeah. I think that's what I've been doing actively as well. I've been trying to create things. I've been trying to create tickets for myself in the future, um, and hopefully at some point of time I'm able to achieve them, or at least a few of them for sure.
Have you ever encountered a situation wherein you have used multiple sub-classifications of a classification inside a single piece of code itself?
Yes, there have been few instances of such. There was one particular piece of code that I was writing, where the parent interface had an abstract factory, and each of these factory methods would internally again instantiate an object using a builder pattern. So I was able to find that sweet spot to employ or use both these design patterns. There is one more thing I would like to add here. There are situations where I have used multiple design patterns from different classifications together. For example, I was working on a piece of code where the creational pattern was a factory pattern, and each team was supposed to own their classes of functions or methods. And the idea was this would give a clear separation of concerns, and and will have a well-defined ownership. Similarly, the structural pattern of this function or class that I was building had a composite pattern. That means the methods would internally be composed of different functions together. And the idea was we should be able to break uh, the mega function into smaller units, which can be well unit tested in isolation. Each of these functions would again be owned by different teams, depending upon the area of expertise, which kind of resembles to the chain of responsibility or a behavioral pattern uh, that was relevant here. So indeed, there are situations where we have to use different patterns together.
This whole explanation made me think about microservices and how we abstract a lot of these things into microservices of their own so that the developers have to only focus on one thing at a time and not just think about the whole mega structure.
Definitely, I think it is very well applicable to microservices, micro front ends, um, and a lot of places in software engineering in general. A general rule of thumb that I follow is design happens top down. You
Mhm.
would, for example, I know I want to build this, and then you keep on investigating what are the smaller pieces you need, and as you go. But development big is generally bottoms up. If it's a tree kind of a structure, that means you'll start small and then you'll keep on gluing pieces together until you get the entire piece of software. So that's something that I'm able to correlate with.
I think it's beautiful how we decompose every problem into a very small chunk and then tackle that one at a time
Yeah,
and keep going. That makes software development one of the most interesting things, as well as you have to be ruthlessly persistent.
definitely. And I think that's the best note on which we can end today. Let's be ruthlessly persistent.
That's definitely a good note to end this video, but I think we should also continue this conversation in the Discord server. If anyone has any questions, feel free to join the Discord server and continue this discussion there.
Definitely. Let's take this conversation to Discord. In the meantime, I think I would ask people to subscribe, like, and share. And thank you so much.
And comment.